Welcome back, everyone. In this lecture, we're going to go over the solutions for the NumPy exercises. Let's head over to the exercise notebook and get started. Okay, the first thing we had to do was import NumPy as NP, and then we were asked to create an array of zeros. Keep in mind, there's probably multiple solutions for each of these questions, but in general, we'll try to do the simplest ones. So NP zeros, if we want 10 of them, we just need to say NP zero is 10. Same thing for ones, we just say NP.ones, and then pass in 10. So here we see the 10 ones. For fives, there's lots of different ways you can do this. You can either say NP1's 10 and then add 4 to it, or multiply it by 5. So lots of different ways to do this. Create an array of integers from 10 to 50. So again, different ways we can do this. One way is to simply use NP_arrange and then go from 10 all the way up to, but not including 51, and then that will get you 10 through 50, all the integers there. 6 was to create an array of all the even integers from 10 to 50. Same approach, except this time we'll add in a step size of 2. And here we can see the even numbers. Next, we wanted to create a 3x3 matrix with values ranging from 0 to 8. So different ways we can do this. One way is to first say NP_arrange 9, and that will get us the actual values, and then we can call reshape off of this as a 3x3, and there we have 0 through 8. So you can actually stack these sort of method calls, or if you want, you can use assignment as well. So you could say something like array is equal to NP_arrange, and then reshape like this, and that's the same thing. So you can either stack them or have them in multiple steps. It's really up to you. Then we wanted to create a 3x3 identity matrix. That's just going to be NPI with a 3. And the next one was to use NumPy to generate a random number between 0 and 1. For that, we simply use np.random.rand, pass in 1, and there's our random number. Next, we wanted to use NumPy to generate 25 random numbers sampled from a standard normal distribution. Remember, that's going to be np_random.randn 25 for 25 numbers. For this one, we wanted to create this following matrix. So it's a little tricky, but basically you had to realize that we're going from 0.01 to 0.02 to 0.03. So it looks like our step size is 0.01. And there's actually lots of different ways you can do this, but one kind of clever way to do this is by saying NP_arrange from 1 to 101. And if you do this, you'll notice you now have the same values, 1, 2, 3, 4, etc., except we're just off by 2 decimal places. So then we could say divide this by 100, and now we have the correct values. Except notice the shape here, this is just a single array, so we can see there's one square bracket, but it looks like we need this in 2 dimensions. So I'm going to assign this as an array, and then I will reshape this to be a 10 by 10. And now we have the same array. And if you want, you can do this all in one step as well, as shown in the solutions notebook. Next, we wanted to create an array of 20 linearly spaced points between 0 and 1. For this, basically just call in space, go from 0 to 1, and ask for 20 points linearly spaced. After that, we had NumPy indexing and selection. So we run this cell, so this is our starting matrix. So we go ahead and run that. So now we've defined this matrix. And next is to write code that reproduces the output shown below. So if we take a look here, we want to grab 12, 13, 14, 15. So it looks like we want to grab this chunk for these 3 rows. So how do we do this? We simply say the matrix object, and for the first one, we're going to start at row 2 and then go all the way to the end. So here I can see I have those last 3 rows. Then for the columns, what I want to do is start at column 1, colon, and then go all the way to the end that way. So that now gives me that same block of that NumPy array. Next was to write code that produces the output shown below, which is just a single 20. For this, we simply had to call the index location, which is at row 3, column 4, you get 20. And then finally, this one's a little trickier, but it's to write code that reproduces 2, 7, 12. If we take a look at our original matrix, 2, 7, 12 is right here, 2, 7, 12. So we apply the same logic. We're going to grab all the rows, starting at the beginning, all the way up to row 3. So if we take a look at that, we have the rows that contain 2, 7, 12, and then we actually just want a single column, which you can grab as a slice from 1, colon, all the way up to but not including 2, so that's just going to be 1. If you were to only provide 1 like this, that would actually give you the values, however, it wouldn't give it to you in the same shape. So you'd have to use slicing if you wanted to retain that original two-dimensional shape. Next, we want to write code that reproduces the output shown below here, 21, 22, 23, 24. That's simply mat 4, so row 4, all the columns. That's the same thing. And you could have also just said, if we write mat 4 here, those are the same values. So up to you which way you want to choose. Next, to write code that reproduces this below, very similar thing. We say from rows 3 to 5, give me all the columns, or you could have said rows 3 to 5 this way. It's the same thing either way. Okay, finally we have some NumPy operations, which is to get the sum of all the values in mat. So that's simply going to be mat sum through 25. To get the standard deviation, and for this you had to check the notebook, it was referenced there, but it's going to be std for standard deviation. Again, we mentioned that there's a link there for all the universal array functions that exist for NumPy. And then to get the sum of all the columns in mat, we simply had to say mat sum axis equal to 0. And then finally, for the bonus question, so we worked a lot with random data of NumPy. Is there a way we can always ensure we get the same random numbers? You can click here for a hint, but we also mentioned this during the lecture, and that's simply to say np.random.seed and then pass in some arbitrary number choice. And then if you're following along with me and you ask for some random number, it should give you this exact number if you run these both in the same cell as I did. Okay, that's it for the NumPy exercises. Don't worry too much if you weren't able to get all the indexing and selection exercise for the two-dimensional arrays. We won't be doing that too often throughout the course. Instead, just focus on the concept of being able to take slices from one-dimensional arrays, since typically our time series data will just be a single one-dimensional array that's timestamped. Thanks, and we'll see you at the next section of the course.